So what is it we are trying to do? We are just trying to find the eigenvalues and eigenvectors. So for A is for an example which is given over here. So for this, we first find the eigenvalues and then find the 5 eigenvectors. So how do we find the eigenvalues? The way to do that will be find the determinant of A minus lambda I equal to 0, where I is a 3 by 3 identity matrix. So to do that, A minus lambda I, we should find out A minus lambda I is, we write A over here, and the lambda you multiply with I, and you'll get the diagonal matrix with lambdas in the diagonal position, and then you'll get, just subtract it, you'll get something like this. So 1 minus lambda, minus 5 minus lambda, 4 minus lambda, other terms being just the same is what we have. Only the diagonal element is going to change from 1 to 1 minus lambda, minus 5 to minus 5 minus lambda, 4 to 4 minus lambda. So having done this, we can find the determinant of this by means of writing the determinant, which is the standard way is 1 minus lambda multiplied by, this 1 minus lambda multiplied by this into this, minus of this into this, and that is 1 minus lambda subdeterminant, which is this, and so on. So the standard procedure, so we'll get the value 16 plus 12 lambda minus lambda cubed. So this quantity should be equal to 0. So we require that this should be equal to 0, and hence we are writing here lambda cube, we are writing other way around, multiplying by minus over here. Doesn't matter, both sides, 0 should multiply by minus, it will become 0. So lambda cube minus 12 lambda minus 16 equal to 0. So this is a cubic equation. Because this is a cubic equation, you can't get a solution straight away. So we look for integers valued solutions. So we try to find out such solutions divide the constant term minus 16. Okay, minus 16 is there. They should divide the terms. So it can be either plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. So out of that, it's definitely not 1. You can check with plus and minus 1. You can check with plus or minus 2. But when you check with 4, it satisfies the condition. So if you take lambda equal to 4, then 4 cube minus 12 into 4 minus 16 will be equal to 0. So the condition is satisfied. So that means lambda equal to 4 is a eigenvalue. Lambda equal to 4 is a eigenvalue because it satisfies this condition. So therefore, now one of the factor of whatever is given there is lambda minus 4. So if one of the factors is lambda minus 4, out of this overall thing, you can divide this by lambda minus 4. You can divide the lambda cube minus 12 lambda minus 16 by the value which is lambda minus 4. Then you will get the quantity which is here, lambda squared plus 4 lambda plus 4. Okay, in place of lambda, in place of x, you have a lambda, that's all. So it's not a, it's just a, a cubic equation. Whatever we have here is a cubic equation. And if you get this value, then that is the factor over here. If you want to divide this by a, divide this by divide with this, the cubic equation which is already given, then you are going to get a quadratic equation over here. So once you get this quadratic equation, you need to find the roots of this. We know the roots of this straight away. Either you can use minus b plus or minus root of b square minus 4ac by 2, or you can just straight away factorize this. So either way, you will get the root lambda equal to minus 2, which is a repeated root. Okay, two roots of the same value lambda equal to minus 2. Therefore, the eigenvalues of A are lambda equal to 4 and minus 2. So two values, 4 from here and minus 2 from here. So lambda equal to minus 2 is a repeated root of the characteristic equation. Whatever lambda squared, lambda cube minus 12 lambda minus 16 equal to 0, that is known as the characteristic equation. And the eigenvalues themselves are known as characteristic values. Eigenvectors are also known as characteristic vectors. So once the eigenvalues of the matrix A have been found, we can find the eigenvectors by means of Gauss elimination. So in the step 1, for each, so now eigenvalues have been found, we need to find the eigenvectors. For each eigenvalue lambda, we have A minus lambda into x equal to 0, where x is the eigenvector associated with the eigenvalue lambda. So step 2 is find x by the Gaussian elimination, that is convert the augmented matrix. So we have the augmented matrix A minus lambda I colon 0. Okay, the A minus lambda I should be equal to 0 in the matrix format, in the matrix format, and into x basically it just means A minus lambda I into x is equal to 0, and that will make us write the augmented matrix like this. We should convert this into the row echelon form and solve the resultant linear system of back substitution. So we find for the eigenvectors associated with each of the eigenvalues. So first, for lambda equal to 4, case 1 is lambda equal to 4. So we must find vectors x which satisfy A minus 4i. So lambda is 4, is 4i x equal to 0. So A minus 4i will be this value. A minus 4i will be this value. So once we have this value, then you need to write the augmented matrix, that is A over here and 0, 0, 0 here. So now this is R1, this is R2, and this is R3. We know that very well. And we should now convert this into the row echelon form, which we already know. So what do? We should somehow make this equal to 0, right? First, he's just dividing it by, you can just do that like that also, or he's first dividing here the R1 by minus 1 by 3, so that he makes this value equal to 1. So 1, 1 minus 1, 0 is what we are getting here. After doing that, then we should try to make this equal to 0 and then this equal to 0. For that, we should write R2 will be replaced by, the arrow should have been other way around. R2 should be replaced by R2 minus 3 into R1. R2 minus 3, R2 minus 3 into R1. So you multiply 3 with R1 and subtract from R2, you'll get a value 0. So 3 minus 3 into 1 will be 0. Minus 9 minus 3 into 1 will be minus 12. 3 minus of 3 into minus 1 will be 6. 0 minus 3 into 0 will be 0 itself. Similarly, you want to make this as 0. So for that, we should write R3 minus 6 R1 should go into R3. Okay, R3 minus 6 R1 should go into R3. And that is 6 minus 6 into 1 will be 0, and that goes here. Minus 6 minus 6 into 1 will give us minus 12. And again, you can try to find out the other value. 0 minus of minus 6 will become 6. 0 minus of 0 will become 0. So now both these have become 0. Now the next one will be to make this equal to 1. So we are dividing that by minus 1 by 12. So we are converting this into 1 over here. And if you want to convert this into 1, you are dividing by minus 12. So this will become 6 by minus 12 will become minus half. 0 by minus 12 will remain 0. And this will remain same. And if you just take over here R3 is replaced by R3 plus 12 into R2, you are going to get all zeros over here. So having got that, then we can try to make this value 0 and then this value also 0, so that we get the reduced row echelon form. So for that, if you want to make this 0, then R1 minus R2 should go into R1. So then this will become 0. R1 minus R2 is equal to should go into R1. So this, 1 minus 1 will make this 0. Minus half of minus 1 will become uh, minus R1 minus R2 is going there. Okay, it all depends upon you. R1 minus R2 or R2 minus 1, R1. So minus 1 minus of minus half will be minus half, and then the value of we should, when you want to make this 0, then naturally it should be R1 minus R2, not R2 minus R1. If you make R2 minus R1, then that will become equal to minus 1. But we want this to remain 1, so therefore it is R1 minus R2, so that this quantity is made 0. Okay, so this value will become minus half, and this will remain 0. So now you can see that, this, these two are the pivot variables, whereas this becomes a free variable. X3 is a free variable. X1, X2 are pivot variables. So we need to represent the, what you call, pivot variables in terms of the free variable, which is X3. So for that, we try to write the equation corresponding to the, this one, X1 minus half X3 is equal to 0. Here, X2 minus half X3 equal to 0. Both the things we are writing over here. Okay, that just gives us X1 is equal to half of X3, or X3 by 2. X2 is again X3 by 2. So we are trying to substitute over here. We are just trying to find the value of X, and that will be X1 equal to X3 by 2, X2 equal to X3 by 2, and X3. So if you take out X3 comma, it will be half, half, and 1. So thus we'll get the value of the eigenvector X corresponding to lambda equal to 4. Then we go for lambda equal to minus 2, and for that we'll have to write a plus 2i. Lambda equal to minus 2 will give a plus 2i for a minus lambda I, and that we can try to again find out that over here. So to construct this, again we go for the augmented matrix, and for that you divide by 1 by 3. The first row will get this. The second row should be, again I want a 0 here, should be subtracted from the first row for making this value 0. But meantime, to do that, when you multiply this R1 by 3 times and then subtract from R2, you'll get all these terms zeros here. Similarly, if you want to subtract from, so to say, what you call R3, 6 into R1, then again you are going to get this value as R3, zeros. So once you get this, this is the only pivot variable, and these two just correspond to the free variables. Okay, X1 is the pivot variable, X2, X3 are the free variables. So you will get here X1 plus X2 minus X3 is equal to 0. You need to write the pivot variable in terms of the free variable, and that is what we should substitute here. Last time also that is what we did. The pivot variables are represented in terms of the free variable, and then we substitute in place of the pivot variables the corresponding free variable term to get the X. Similar thing we do here. X1 is equal to X3 minus X2. So coefficient of X3 here is 1, coefficient of X3 here is 0, coefficient of X3 is 1. So therefore 1, 0, 1 into X3. Coefficient of X2 is minus 1 here, here it is plus 1, here the coefficient of X2 is not there, that is equal to 0. So minus 1 plus 1, 0 multiplied by X2, 1, 0, 1 multiplied by X3. So thus we get the eigenvector here associated with lambda equal to minus 2. So that is how we can get the solution detailed solution is given over here, right? So the solution of Ax equal to lambda x. Another example is what we are doing here. For -5 to -3, you'll get this a minus lambda I is equal to this. You solve this, you'll get lambda squared minus lambda minus 2. You can just take the quadratic equation solution. Lambda is equal to minus b plus r minus root of b squared minus 4ac by 2a. If you do that, or you can factorize it also, it all depends upon you. He has just factorized it and he's got lambda plus 1 lambda minus 2. So two eigenvalues, lambda equal to -1, lambda equal to +2. So for each of those eigenvalues, which is -1 and +2, either by the means of this square quadratic equation, quadratic solution of quadratic equation, so equation, or you can factorize it. You'll either way get this value. So there are two eigenvalues because we have a quadratic, the quadratic has two roots. We had a quadratic, lambda squared minus whatever. So the values of lambda equal to -1 and lambda equal to 2 lead to the solution of this. So for lambda 1 equal to -1 value, a minus lambda 1 I x is equal to 5 minus 5 2 minus 2 yz equal to 0 0. So for this we need to get the solution here, or for that matter we should try to find out the eigenvector to find the solution for yz, that is the value yz. Okay, the solution for this will be 1 1. Again, procedure to be followed is just the same. You need to do the Gauss elimination and try to do that. That's the best way to do it. From straight away from this also, by looking, if you can make out, if you multiply 1 with 5 and 1 with -5, you are going to get a 0, and that is true here. 2 into 1 minus of 2 into 1 will become 3 minus 3, that will be equal to 0 here. So the solution of the first eigenvector is any non-zero multiple of x1. Eigenvector for lambda 1 is x1 equal to 1 1, and you can say multiplied by c1 over here. Similarly, the computation for lambda 2 is done separately, that is lambda 2 equal to 2 will be, again you can write this and try to find out the eigenvector for the lambda 2, and that will become 5 by 2. So best way is to do the Gauss elimination, which we have done in the earlier problem. Similarly, you can try to do for this on your own, right? So if you have doubts, any doubts you can ask till now.